like one side.
Morning, everyone. This time we're going to work on regression. Please go to our shared lab notes and find the section called Regression with Excel. You should be able to find the link to our shared lab notes on the homepage of our Canvas website. Okay. Just like the section where we worked on linear programming, if you have not enabled the regression tab, which is under the data ribbon, and in a section of data analysis, then you should be able to enable that by going to File and Tools, File and Options, and you should enable the add-in that's called Analysis Tool Pack. Once you enable the Data Analysis tab, you should come here and download the survey results from this link that I provided. It's on a real estate sales record of 522 houses. And for our demonstration, we are going to make a small model to start with. Here, I set up a model so that the research question is to find the valuation of a swimming pool. And because it's about a swimming pool, so I used whether a house has a swimming pool or not as one of the predictors. And in the survey results, this is called as pool as the column name. And because I want to assess the valuation of it, that's why I use the sales price as the response, or the dependent variable. And as you can see here, the basic model to start with has price as the dependent variable and the pool as the independent variable, also called as explanatory variable. All right, now given this model to start with, we need to estimate two parameters in the model, which is the intercept and also the coefficient or the slope of pool. They're called beta 0 and beta 1 respectively. Okay, now let's demonstrate how we can estimate this model. Starting with the downloaded file, you will see that there are a few columns in the shared document of the survey results. Raise your hand if you finished downloading the survey results. That's a Excel file. Are you all good? Okay, have you all downloaded? Okay. Okay, yeah, please do so because you need to work on it. You will find that there are 11 columns in the downloaded file representing 11 different fields. And you will also find that there are 522 rows. In my sheet, I sorted the rows and also changed the order of the columns so it may appear slightly different than what you see immediately after downloading. All right, anyway, to estimate the model that I illustrated earlier, we would go to the data ribbon and find the data analysis button under the analyze section. In the pop-up window, you see a list of different analysis tools. Scroll down until you find the option called regression and click OK. Here you see a window where we need to set up the model. First, we need to specify the input Y range. This is where we need to supply the cells that includes the response variable that stands on the left-hand side of a regression model. Click it, you will see that a region selection area is highlighted. Now we need to click the column of B. I think you will need to select both the first and the last cell in this column. And if you select only the entire column, it probably won't work. So what you need to do is to either select the whole column and input the row index, that's 1 to 523, or you select both the first and scroll down until the last cell. All right. Next, I specify the input X range. That's where the explanatory or predictor variable is. Again, I select the first and the last cell in the pool column. In my sheet, that's column F, but in yours, it may be under a different column. All right, both done. Now we need to specify whether the columns includes the first row as the variable name. In our case, yes, the first row has the variable name, so we make this check. Constant is 0. This option enables you to specify the model so that it does not include an intercept. But in our model, there's an intercept, so we do not make this check. And we also want the model output to include some confidence intervals. By default, the 95% confidence interval is already included, so we can let Excel to generate some other confidence intervals that might be interested, that might be interesting for us. So here I specify the Excel to return a 90% confidence interval instead. Okay. Next step, we specify where the output should be. In my case, I really prefer to generate the output in the same worksheet and in Excel. So I click this and select the top left cell to hold the output table. So in my case, I selected the cell N1. And you can also make the check to let Excel return the residues, the standardized residues, the residue plots, and the line fit plots. And there is also an option to return the normal probability plots. Okay, let me know once you finish selecting all these required sections in Excel regression tab. Okay, are you all good? Any questions? Okay, once finishing selecting all the options, we simply click OK. And you see that there's a section highlighted that holds the summary output. These are 3 tables. First one is called regression statistics. Second is ANOVA, and the third one holds all the coefficients in the model. Do you see this section of tables generated in your Excel? Okay. All right. Now let's work on some activities in this lab section. We already finished all the steps in the regression with Excel. Now let's work on some of the questions. First part of the question regards study overview. Okay, here our research question is the evaluation of a swimming pool, or in daily language, we could say how much is a swimming pool worth in a sale of a house. Okay, and here in the survey, to see how many variables we have collected, we simply see how many columns it includes. However, in our survey results, we also have an ID column that simply is a row index. So this doesn't really count as a variable. So instead, we should give a count that's 11 columns remaining. So we have 11 fields or 11 variables collected through the survey. To find the range of each column, we can use Excel functions that's minimum and maximum. But there's also a shortcut that we can take that gives us an intuitive and quick answer to such questions. The way we do so is that we select the region that has the survey results and go to home. There's a tab called sort and filter. Click it, you see there's an option called filter. And click it, you will find that to the right of each column names, we have a drop-down menu now. And if we move, let's take sales price as an example. Click this drop-down menu or button. To the right of the column name, we see there's a list of all the unique cell values in this column. And we find that they are all sorted from the smallest to the largest. So going from the top that has 84,000 to the bottom that has 920,000, we find both the smallest and the largest value held in this column. Any question here? Okay. So this is a quick way to find the range, which is essentially the smallest or the minimum to the largest or the maximum. Okay. Although that our research question is the valuation of a swimming pool, many of the other columns are also relevant, can be relevant in this research question. This is because if we want to find how much a swimming pool is worth, we can or we do not hold constant the other cells that are also relevant or associated with the sales price. For example, it's quite reasonable to suspect that the square footage of a house is related to their sales price. A larger house is probably worth greater on average. So if we want to control the square footage and see the effect of whether or not a swimming pool is in a house, we can do so by include another variable. Okay, I also encourage you to check the data visualization that I mentioned at the beginning of this data exploration section, but we will not go through it this time. Okay, now let's find some descriptive statistics of the most important variable. Okay, now in the linear model property section, we need to fill out this empty sheet that mimics our regression summary output. In an earlier step, we already estimated the model. Let's see how we can regenerate all the results from this table by using the property in a linear regression model. So let's fill out the highlighted cells in this table. We're given the number of observations, that's 522. And this model, we can find the name of the values, right, of the coefficients. First is the intercept, and the second is the pool. Because in our model, we are trying to estimate the sales price using pool as one and only one explanatory variable. Given these, we know that we have only one predictor. That's why the degree of freedom for regression is 1. And this total degree of freedom is the number of observations minus 1. So this is 521. Given that we know that the residue is the remainder when we take 1 out of 521. So this is 520. And in this column, we have SS. It represents sum of squares. Because it's called sum of squares, they must sum to something, right? So here the property is that the sum of squares of regression and residue sum to the total sum of squares. So to find the regression sum of squares, we simply would use the total sum of squares and subtract by the residue sum of squares. So in my case, it's the result of a P32 minus P31. In your case, it might be 2 different cells. So the sum of squares of the residue can be found by using the total to minus the residue sum of squares. And here, after that, we have a column that's called MS. That's mean sum of squares. When we mention mean, we need to find the mean, right? So how we find that is simply we use each of the sum of squares and divided that by degree of freedom. So here, if we divide sum of squares by residue, then we also need to find the same thing for the regression. And because for the regression, the degree of freedom is just 1, so the mean square is the same as the sum of squares. And this F value is found by the ratio of these 2 mean squares. So we would use the regression mean square to divide by the residue mean square. This gives us the F value, which is 11. And the significance, we would use the F distribution. So we find the formula that's F dot distribution useful. So we need to give X, that's the F value we just calculated. The first degree of freedom is the degree of freedom of regression, that's 1. And the second degree of freedom is 520. That's the residue degree of freedom. And we want to find the cumulative. So we type 2. And by default, this gives us the lower tail of the distribution. So we need to use 1 to minus this probability, which gives us a very small value that starts with 7 after 3 decimal places. This is exactly the same as what Excel generated as part of the summary output of the regression model. And to find the R square, we can use the calculated ANOVA table values. This is done by finding the residue, the regression sum of squares, and divided by the total sum of squares. And as we can see again, this is exactly the same as what's returned by Excel regression output. And given the R squared, the multiple R is simply the square root of the R squared. So we find the square root of the R squared, which is the multiple R. This is effectively the correlation coefficient between the variable that's pool and the dependent variable that's the sales price. And to find the missing cells in the regression table, a T statistic is calculated as the ratio between coefficient and standard error. So it's coefficient divided by standard error. So it's almost 44 for the intercept. To find the standard error of the pool coefficient, again, we use the same formula. So we divide the coefficient by the T statistic. So effectively, what we learn from here is that a T ratio is defined by the estimated coefficient minus 0 and divide by the standard error. And because we minus 0, it doesn't really do anything, right? So we can simply use the estimated coefficient, that's beta, to divide its standard error. All right, now I encourage you to finish the rest of the activities on yourself. But here I complete the last part of our lab session. Oh, okay. Maybe I can also do the standard error part. The standard error is found by
Oh yeah, we didn't exactly finish. You cover a lot of it. Like that's fine, right?
yeah.
Okay.
Really?
Yeah, that's